Again,
So everybody's fine.
Yes, sir.
Yes, sir.
So out of 20, how many of you in the campus right now?
so 4.
Oh, okay, only four. Fine. So can we expect more, or this is the final number, 13?
So 3-4 more people are coming.
Okay, then fine. We'll wait another 2-3 minutes then. So did you do the last program which I told you to do?
Yes, sir.
Yeah. So some of them just copied. I could see their report, but some of them did very well. Like they written very clearly the like each instruction what it is doing and all. So that's actually good. So some of them did very well. I'm happy for that. Yeah, you're supposed to do that only. Like each instruction you have to write like what it's supposed to do, like what it is doing for the program and all. So some of them did it very well. And how about the theory classes? Where it is right now in the theory? Entire instruction set is over. Can you hear my voice or not?
Yes, sir.
So what about interfacing part? Any interfacing part is discussed?
No, sir.
Not yet. Okay, fine. So in that case, I think we have to give break for 1 week again in the next week, because the next lab session will be on interfacing, but that should be covered in theory before we proceed to that one. I think we can start. It is fine. So it's almost 10:10. So let them join maybe 1 or 2 minutes little late. It's fine. So let me share my screen. So are you able to see my screen, all of you?
Yes, sir.
Yeah, fine. So this is your today's program. So you have to guess what is the program. Can you guess some program name based on the picture? Are you able to guess or not? At least that is also fine.
No, sir.
No, okay. Any other? Try. Think behind the box and check. Okay, at least tell me, what did you understand from the figure? That is also fine.
Air bubbles.
Air bubbles or soap bubbles?
So bubble.
Okay. Then next observation. Did you see them? They are ordered in a one particular order. Did you observe that? Soap bubbles are maintaining one particular order. Did you observe that or not?
Yes, sir.
So what is order? Increasing size or decreasing size?
Decreasing in size.
Or increasing size also, right? Both are okay, right?
Yes, sir.
So it
Yes,
can be
sir.
either top to bottom or bottom to top, right?
Yes, sir.
So actually, this is called bubble sorting. So you must have heard it in C language, probably C++ or something. Arrange
Yes,
the
sir.
numbers. Arrange the numbers using bubble sort method. Actually, bubble sort comes from this logic. So when you take the soap bubbles, they arrange themselves in a particular order, either ascending order or descending order, depending on which direction you are looking at it. Suppose if I look from the bottom, it is ascending order, like it is starting from small bubbles and expanding to the large bubbles, right? Similarly, opposite side also, it start from bigger bubble and goes to the lower side. Like so that's why that particular that sorting out the numbers, either increasing order or decreasing order, we call it a bubble sort. So the reason why that name has come because of this particular behavior. Hope you got the program for today now? At least tell me now what is the program for today?
Ascending
So
and
sort
descending
numbers
order.
and
Yeah.
ascending and
So
descending.
you're going to sort out the data array. That means a group of data points which are stored in a memory location. So some numbers will be stored in memory location with a random order. So you're going to make them in a particular order, either ascending order or descending order. So one of the two things we are supposed to do. So as far as today lab is concerned, I'm going to show you how to arrange them in ascending order. And descending order, you have to do it as assignment and submit in the LMS later part. Okay. So we'll start enter into the lab program, like how we are supposed to do and all. Okay. So this is the program. So program to sort an integer array in a ascending order fashion using emulator 8086. So listen carefully. These are these are the data inputs of mine. So this is the data. This is the data which is stored in this memory location. Listen carefully. Your data is stored from 1200 memory location to 1204 memory location, and you need to order these numbers in the ascending order. So by the time you run this program, you are supposed to expect the numbers in the memory location should be in the ascending order. If you look at here, your numbers are ascending order 1, 2, 3, 4, 5. Is this clear what you're supposed to do exactly?
Yes, sir.
So this is what you're supposed to. You will be given some random numbers, or I will be giving some random numbers, ask you to store in particular memory locations, and you are supposed to write a program so that by the time you run your program or execute your program, the number should arrange in the ascending order fashion. So this is what you're supposed to do in the current lab session. Okay, fine. So is there any worst possible combination other than this? This is the worst, or this is the best possible combination for input data? This is the worst or best? Tell me, worst or best?
Sir, West.
This is a worst combination. Anything more than this will happen?
Yes, sir.
More than this?
4. Yes, sir.
This is completely opposite what you are expecting, right? Anything other than this happen? I mean, other than the, like any other combination worse than this?
No, sir.
This is the worst combination, right?
Yes, sir.
You are taking a descending order numbers and you are making them into ascending order. This is the worst combination one can think of it. So we'll take this as a challenge, because if you have some random numbers, it will be easy. But if you take the worst combination, we can easy to do that. Okay. So we'll try to understand the logic, how we are going to do that. Okay. So first we need to understand the logic, how we are going to do that. So, okay, if you want to make the numbers in ascending order, okay, like say in increasing order. So what we are supposed to, we are supposed to compare the numbers. Agree, all of you?
Yes, sir.
You have to compare the adjacent numbers. Then only you will understand that whether the given numbers are equal or greater or less than whatever it is. So that means the compare instruction will play a major role. So the CMP will play a major role in arranging the numbers in ascending order, descending order. So this is the basic logic you're supposed to remember. That means you are going to use the compare logic to make the numbers in the ascending order or descending order. Okay. So we'll take the worst combination as usual, as I said, 5, 4, 3, 2, 1. Now tell me how many times I'm supposed to compare if I want to compare 5.
4.
4 times.
4
4
times.
times.
Okay. So 4 times you have to compare. So after 4 times you will get another sequence. Agree, all of you?
Yes, sir.
So after that I need to compare once again, or that will be final result?
That will be final.
Okay, that's not final. You have to do it some more time. Anyway, I'm going to show you how we are going to do that. Okay, listen carefully. So this is the input data. Listen carefully. This is the input data. What we are going to do is, first we are going to compare 5 and 4. Listen carefully. So I will move this to AL register and compare with SI, whatever the SI value, or SI plus 1, whatever it is. Okay. Listen carefully. Whatever the data you will be given, first you are going to compare two numbers like 5 and 4 here. So you are going to use compare instruction, compare AL comma SI, whatever the memory location which you defined. Okay. So when it compares, then followed by you're going to write one instructions, a jump, carry, and exchange. Listen carefully. So after comparing, your program going to follow these instructions. Okay. In this case, when you compare 5 and 4, the carry will be generated or not?
No, sir.
No.
Yes.
So whenever there is no carry, it's supposed to execute the instruction exchange AL comma SI. Listen carefully. Okay. So if you look at here, first to second, what happened? First, it has taken two numbers, 5 and 4, it compared. 5 is greater than 4, no carry is generated. So it is exchanged the numbers. Agree, all of you? Say yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. So first, this is done. These two numbers are compared now. Now this has moved here. Now what I'm going to do, I'm going to compare these two numbers in the second iteration. So again, 5 and 3 will be compared. Carry will be generated.
No.
No, sir.
So when no carry generated, you have to exchange once again. Is that fine?
Yes, sir.
So step 2, your 3 and 5 are compared. Now I'm going to compare 5 and 2. Again, carry will be generated.
No, sir.
No, again there will be exchange. So this is step 3. So again 5 and 1 are compared. Again carry will be generated.
No, sir.
No. So no carry, that means exchange. No carry, exchange. No carry, exchange. So in all the cases we did not encounter any carry. So in all the cases your number has been exchanged with the next number. So at the time you finish step 4, the highest number in the series has moved to the last side. Is that fine, all of you?
Yes, sir.
So how many times you compared? 1,
4 times.
2, 3, 4 times you compared, right? So that means you have to keep the counter as 4 times, or whatever the counting value. So you are supposed to keep counter value as 4 because it need to compare 5 numbers. Remember, when you want to compare 10 numbers, your counter supposed to set to 9. Or if you want to compare n numbers, you are supposed to keep counter number as n minus 1. Is this fine, all of you?
Yes, sir.
Yes, sir.
So this is for first iteration. So is this final sequence or do I need to do one more iteration?
We need
One
to do
more.
more iterations.
You need to do at least another
3.
3, exactly. You need to do another 3 iterations. Listen carefully, you need to do another 3 iterations. But this time the sequence start from which place?
Second place.
Now this one, right? The sequence start from these numbers. Like you are going to take this as a reference in the next cycle, right?
Yes, sir.
So in the next cycle, we are going to start from the previous values which was stored. After this entire loop is executed, you end up with 43215. Now then this is a new cycle again. So 43215. Now you're going to compare 4 and 3. So carry will be generated?
No.
No. So when carry is not generated, what you are supposed to do?
Exchange.
Exchange. So exchange 3 and 4 done. Now this time 4 and 2 will be compared. Again carry will be generated?
No, sir.
No carry. No carry means
Exchange.
exchange. So exchange. Now again 4 and 1 will be compared. Is there any possibility for the carry?
No, sir.
No. Again exchange.
Exchange.
So exchange is done. Now 4 and 5.
Carry will be generated.
Carry will be generated. So whenever carry will be generated, it goes to the first loop. Okay. So here nothing will be happen. No exchange will take place. Okay, it will just go to the starting loop. So by the time you finish your second iteration, this is your final output. Is this final or do I need to do two more iterations? Two more, because you need to compare this and this also. Okay, so in the next iteration I'm going to take this as input because this is the final state of your memory locations. So 3 to 145. So I started with 3 to 145. I'll compare 3 and 2, no carry, so exchange. So 2 and 3 is exchange. Now 3 and 1 will be compared, no carry, exchange. 1 and 3 is compared, and 3 and 4 is compared, so no, it will go to the loop. Fine. So again, do I need to do one more or it's over?
One more.
One more. So one more, you are supposed to take this as an input for the next iteration. So 2, 1, 3, 4, 5. So you start with 2, 1, 3, 4, 5. So you are going to compare first element, no carry, exchange. Okay. Then after that, 2, 3 carry will be there, 3, 4 carry will be there. So there won't be any execution. So after this, you are going to get our final output. Is this fine? All of you first tell me, is the logic is fine for everyone?
Yes, sir.
So how many loops are there total?
4 loops.
Total,
No,
how
one
many
loop.
loops?
7.
2 loops are there, right? Total 2 loops are there. Listen carefully.
Okay.
One loop is doing comparison. Agree, all of you?
Yes, sir.
Yes, sir.
One loop is doing comparison. Another loop is giving next cycle. Agree?
Yes, sir.
So every time, so all these things are individual. This is one loop. This another loop. This another loop. This everything comes under comparison loop. But every time you are starting with a new sequence. So first we start with 5, 4, 3, 2, 1. Then 4, 3, 2, 1, 5. Then 3, 1, 2, 4, 5. Then 2, 1, 3, 4, 5. So that means you need to have another loop that is for the entire numbers. So it means you need 2 counters, one for comparison, one for entire loop. Is this fine, all of you?
Yes, sir.
Right. So that means you're supposed to perform 4 iterations of comparison and 4 iterations of full cycle. Then only you'll get the final output. So we'll see further, like what are the instructions you are going to use, how the program look like, how it is going to give the output. Okay. So this is the logic. If there is a confusion, don't worry. You put it on a paper and do it on your own, the same analysis. You will understand it. It's not a big deal. It's a very simple thing.
Sir, I have a doubt.
Yeah, please.
Sir, why we are using a jump carry while comparing? We can use also, we could have JG or JL also.
It's up to you, whoever it may be. See, the microprocessor has wide variety of instruction set, so you can use according to your logic. There is no restriction.
So what is the need of using carry here? I don't understand.
So when you compare 2 numbers, it gives information whether the 2 numbers are equal or greater.
Then we could have used JG greater than or equal to. Like
That's
that.
what I'm telling. That's what I'm telling. It's a designer choice which instruction you want to use to compare 2 numbers. That's it. See, this is not standard. I said in the first class, each program will be based on their own logic. There is no restriction that you can generate a same program which also does the same job with a different instruction set also. There is no problem.
So we can use that also, right?
Absolutely, absolutely. You are free to use. Only thing is, provided you have to check your result whether it is working properly or not. Okay.
Oh, okay. Sir.
See, this jump carry, I used it because this is the simplest one which can be done easily. Okay. As far as my program concerned, this is a logic. I found it simplest one to explain to the students. See, if you want to explore different with different instruction set, I'll be very happy to see. Okay. So anyway,
Okay,
yeah, fine. So we'll proceed further and we'll try to see how the program look like, how the loops will be inserted into the program. So you need 2 counters, one for the outer loop. This will initiate new sequence of numbers 4 times. If you have 5 numbers, it will initiate 4 sequence of numbers with a different combination of different order of number, like whether it's a complete ascending order, not completely ascending order, and this inner loop for comparing the individual elements. So these are the two loops you require, and you require the number in the counter should be always number of data points minus 1. That means if you are comparing 5 numbers, your counter should be 4. If you are comparing 9 numbers, counter should be 8. So this please keep it in mind. So n minus 1 should be counter and should be the number of elements. Okay. Now come to the next level, and what are the instructions you are going to use in the program. So as usual, you are going to use the move instruction to move data from memory location to AL register or any desired register, and you are going to use increment to increment the SI memory location, because you are going to compare 4 memory locations. So each time this element will be compared with the next one. That means you have to use increment instruction at this place so that it will go to the next memory location to compare these two numbers. Okay. Then you have to use decrement. This decrement will be decrease the counter values CL or CH value from 04 to 00. Similarly, CH value also 04 to 00, depending upon how many iterations it has completed. Then compare will give you A is greater than B or A is less than B. That means either carry is generated or not. If carry is A greater than B, carry generated or not?
No,
No,
sir.
sir.
No, carry is 0. When A less than B, carry is generated. So depending upon the carry value, we are going to execute the next instruction, whether it should be exchange or should be go to the next instruction. Okay. Then jump carry means depending upon the carry value, it will jump to the desired instruction number. Then exchange, it exchange the adjacent numbers or adjacent memory location. J and Z will be, what is J and Z? You must have studied. Jump,
Jump
If 0.
jump
Not
not
equal
0.
to 0.
Yeah, not
Not
equal to 0, right? Okay. So that means after decreasing your counter values, your CL or CH values, it will check for whether it is 0 or not. If it is not 0, it will go to the desired jump location where it is supposed to jump. If it is 0, it go to the next instruction. So this is a instruction set which we will use for the ascending order program. Now we'll see the program, how it look like. So listen carefully. Initially, I made this program with manual counter numbers. Listen carefully. I'm keeping manual counter number. That means whenever you want to change the number of numbers to be compared, you need to change this manual counter number. So this program is written for to compare, to make 5 numbers in ascending order. Listen carefully. For the timing, we'll go with user defined numbers. 5 numbers you are supposed to make in ascending order. So that's why I'm keeping my counter values as 0, 4 and 0, 4. This is for one loop. This is for another loop. Hope this is fine, I guess, all of you. So this program
Yes,
is written only to compare, to make the 5 numbers in ascending order. Later we generalize this to n number. That we'll see in the next slide. For the timing, let us assume we are comparing only 5 numbers. Okay. So listen carefully. I started origin as usual. So I made my counter as 04H. This is one counter value. For the timing, this loop value don't consider this loop as loop now. We'll come back to when loop has to be started. So we started first instruction as move SI comma 1200. That means you have saved your data points at these memory locations. So this is 1200, 1201, 1202, 1203, and 1204. So this is your first memory location 5, 4, 3, 5, 4, 3, 2, 1. Okay. So first your SI will move to this location. Then you are making another counter value as 04. This is for one loop, this for another loop. Now this is actual program. This is a comparison loop. Listen carefully. This is a comparison loop. So what it does, if you look at here, move AL comma SI. What happens? Tell me here in the first step. What value will be in AL now?
5.
5. Very good. So in the next instruction, what happens? Increment SI. SI goes to which location?
1201.
So next, what it is doing? It is comparing which numbers now? Agree?
Yes, sir.
So now, first it has moved your 5 number to AL register. Then it is comparing this 5 number with the 4 number. If you look at here, compare AL comma SI. SI is 1201. So it is going to compare 5 and 4 first. So when it is compare 5 and 4, next instruction is JC loop 1. So what is JC? Jump carry. Is there any carry here?
No, sir.
So when there is no carry, what is supposed to execute?
Exchange.
Exchange. When it exchange, what happens here? What happens?
Four.
AL becomes 4
Yes, sir.
and 1201 becomes
5.
5. Very good. Listen carefully. This is a very important point. After comparing the numbers, if there is no carry, it is going to exchange the AL value with 1201 memory location. If you look at here, your 1201 memory location is 4. This 4 goes to AL register, and AL value, which is 5, goes to the 1201 memory locations. Now what happens to these numbers now? Tell me what happens to these numbers now. At this place, what happens now? What are the next numbers? Tell me. Is that fine? Say yes or no. Both will be 5, 5. Is it fine?
Yes, sir.
No.
As for the exchange instruction, whatever the SI value, that is at 1201 memory location, will go to the AL register. Whatever the AL register value will move to the 1201 location. So as a result, you are going to get 2, 5. In the next instruction, listen carefully. This is very, very important. Listen carefully. This is very, very important. Exchange SI minus 1 comma L. What it means?
AL value will go to SI minus 1 memory location.
So now what is the next numbers? What is the next
4,
numbers?
5. 4, 5.
4, 5. What happens to your AL value?
4.
4, right? Is that fine, all of you?
Yes, sir.
So now after this exchange instruction, you have got the numbers 4, 5, 3, 2, 1. Now after this instruction, where it goes? Where it goes?
Loop 1, sir.
Loop 1. What it does after that? It decrease the CH value. So CH value means it becomes 0, 3. Then what happens in the next instruction? J and Z loop 2. Tell me what happens at this place?
If CH is not 0, it will jump to loop 2.
Yeah. So here CH is not 0. It will jump to loop 2. Is this fine, all of you now?
Yes, sir.
Now again what happens? Move AL comma SI. Now which number will move to SI now? AL value. Which number will move?
4.
4 will move to the AL. Then again it goes to increment. Again compare with 3. And this loop will go on iterate till how many number? Till what number it will iterate this loop? Till agree, all of you?
Yes, sir.
Till CH becomes 0, this entire loop will execute. The moment the CH becomes 0, it will execute the decrement CL. That means this CL value will be decreased. Once this CL is decreased, it check for whether CL is 0 or not. If it is not 0, it will jump from here. That means you are going back to the starting loop. Again, you are going to start from 1200 memory location. So this process will take place repeatedly till CL equals 0. And once CL becomes 0, you are going to get your output in the memory places. Okay. So this will be more clear when you run the program. Needn't worry. I will run the program and will show you. So let me start my program. So yeah. I did not change anything. Whatever the program we have written there, we are keeping the same program here. Hope this is fine for you. So let me emulate it here. Are you able to see my screen, all of you? Say yes or no?
Yes, sir.
Yes, sir.
Yeah, please watch carefully this input. Now tell me which memory you are supposed to go based on the program.
It's 1200.
So we'll go to the 1200 memory location. So 1200. So which number I'm supposed to give? 05, 04, 03, 02, 01. Is this fine?
Yes.
Yes.
So now my memory location updated. Now listen carefully, watch carefully, step by step I'm moving. This is very important. If you understand this place, it is easy to understand the program also. So first instruction, CL will be set to 4. This is a counter 1 is set. In the next instruction, your SI will move to the 1200 memory location. So SI move to 1200 memory location. In the next instruction, your CH is set to 4. CH is set to. Please remember this program I have written to compare only 5 numbers. I will show you a general number later part. For the timing, we will run this. Okay. Now your first loop, your loop is started here. Loop 2 has started. So move AL comma SI. So that means your 5 number will go to the AL register. So 5 is moved to AL register. Now increment SI, that means it goes to the 1201 memory, that is 4. So 1201 it goes to the 4 memory location where 4 is stored. In the next instruction, this 5 and 4 are compared. Okay, then it look for the carry is there or not. If there is a carry, it goes to the loop 1. So if carry is generating, what it means? Tell me. If carry generated means, are they in correct order or wrong order? If carry is generated.
No, then they are in correct order.
So if carry is generated, when you compare two numbers, let's say 12 and 13, now carry will be generated or not in this case?
Generated.
Generated, sir.
So carry generate, when carry generate, that means it is in the correct ascending order. Agree?
Yes, sir.
Okay.
Yes, sir.
Yeah, right. So the same logic you should remember here. Okay. Nothing else. So fine. So now it is compared 5 and 4. There is no carry is not generated. That means it will not execute the jump carry instruction. It will execute the exchange instruction next moment. So it goes to exchange. In this instruction, the SI content will move to the AL and AL content will move to the SI. So that means your 1201 memory location will be moved with which number?
1200.
5.
5. Very good. 5. So you'll see now. See, these two instructions little tricky. Listen carefully. This exchange AL comma SI, exchange SI minus 1 comma AL. In the first instruction, whatever the AL value will move to SI. SI memory location is 1201. Remember, because we increased SI here. So that means 1201. So whatever the AL value, that is 5, that will be moved to the 1201 memory location. So if I execute the next instruction, you can see here your 1201 memory location is moved with AL value, that is 5. And whatever the value here, that 04 is moved to the AL register. In the next instruction, whatever the AL value, that is 04, will be moved to the SI minus 1. Which location this is?
1200.
1200 memory. That means your AL, that is 04, will move to the 1200 memory location. Now we'll see. Did it move?
Yes, sir.
Yes. So this is a comparison of first two numbers. Now decrement CH. So we are going to decrease. So you can see decrement CH is done. Then it will look for the jump not equal to 0. That means if CH is not equal to 0, it will jump to the loop 2. So now it is 0 or not equal to 0?
Not equal to
Not
0.
equal
Not
to
equal
So
to 0.
not equal to 0. That means it has to jump to the which loop? Loop 2. Agree all of you?
Yes, sir.
Yes,
So
sir.
now it will jump to the loop 2. In loop 2, what happens again? It will again move SI value to AL. So what is the SI value now?
0,
4.
5.
0, 5. Very good. Again, it will increase the SI register value. That means it goes to 1202 memory location. So that means now, which numbers are compared now?
5 or 3.
5
0,
and
5
3.
and 3.
Yeah, 5 and 3. No carry. What happens if no carry?
Exchange.
Exchange. 5 and 3 will be exchanged. Exchanged.
Yes, sir.
Yeah, 5 and 3 exchange. Then it will decrease the CH value. CH is 0?
No.
No.
No,
Again,
sir.
it goes to the loop. Again, it loads which number now?
12, not 3.
Yeah, what is the number?
2.
2?
5.
5.
0,
Again
5.
5. Yeah, 0, 5. So 5 will be compared with 2.
Yes, sir.
So no carry. So again exchange. 2 and 5 will be exchanged. Exchange is done. Again check for decrease CH. CH is 0 now?
No.
No.
No,
So
sir.
again it goes to one more iteration. So this time which numbers will be compared?
5 and 1.
5
5
and
and
1.
1. Yeah, very good. So 5 and 1 will be compared. Again no carry. So again exchange will take place. Now if you look at here, see, now what happens to your CH value?
CH will be 0 now.
Now if it is 0, it's supposed to execute this instruction, it goes to decrease CL now.
Decrease CL.
Decrease CL.
Yeah, so decrease CL. Now it goes to the decrease CL. After decreasing CL, it look for whether CL is 0 or not. CL is 0 now?
No, sir.
Now if CL is not 0, it goes to the loop 3. That is the starting point of our program. So it goes to loop 3. So that means again it goes to move SI comma 12. And now if you look at the program, now what is the CH value if we run the next instruction?
0, 4.
So again it is loaded with 4 to do 4 more iterations. Agree?
Yes, sir.
So this is how you are supposed to run. I am just running it quickly. You can check the numbers are exchanging. So till your CL becomes which number?
0.
0.
Yeah, right. So we'll make it. Now CL is 1. This is the last cycle. So you can see here. Done?
Yes, sir.
So can you see the numbers? Is it ascending order or not?
Yes, sir.
Yes, right. So I'm giving one more choice. So tell me your own numbers. We'll update it and we'll try to check the program. Give some numbers, man.
9.
09, okay.
4.
04, okay.
6.
06, okay.
2.
Okay.
5.
Fine, done. Okay. So we'll update it. So I'm just directly running single run. So it will run an entire program and show the result. Okay. That's fine. It's okay. So we'll run and check. So 94625. That means you're supposed to get 24569, right?
Yes, sir.
So we'll run. Got it?
Yes, sir.
Yeah, fine. So this is how you're supposed to write your code and you're supposed to execute your code. Listen carefully. This is not universal. You can write your own code, provided it should work. It should give the result which you are supposed to get. This is not the universal code, as I said. This is I took it from many internet sources and other books, and this I found this is the easiest one to do the job, because you need to use only 2 loops, one for the normal comparison, one for the whole set of iteration and all. Okay, this is with only for 5 numbers. Suppose if I want to increase to any number, suppose I want to compare n numbers, let's say I don't have any constraint that I should compare only 3 or 4. Depending on my requirement, I may compare 10 numbers, I may compare 2. In that case, you need to slightly modify the program. Okay, so can you tell me what modification can we do in this program to make it more generalized? What change you are supposed to do to make it more generalized?
Counter register will initialize with SI.
That's it. Very good. So you just make your SI value to some memory location address. So whatever the memory location you're going to give, that will move to CL register. Similarly, whatever the memory location value you give, that will go to the CH register. In this case, now you can enter how many numbers you want to compare at that point of time. It can be anything. The previous program is only for 5 numbers. Whenever you want to increase the numbers, you have to change the CL value, you have to change the CH value. But whereas if you do it generalized way, just you need to enter the memory location, how many numbers you want to compare. So this is the modified program. Listen carefully. So this is same. Agree all of you? This loop is same. I'm sorry, I could not write properly. This is same, right? Yes or no, at least?
Yes, sir.
This is
Yes,
also
sir.
same. This is also same. Where is the change? Where is the change you are observing? Tell me. These 3 lines and
Yes, sir.
these 3 lines. So what we did this time is we moved CL value from a memory location. Instead of giving some manual number, we are given CL value for a memory location. And similarly, we moved CH value also from a memory location. That means from the memory location, we can tell the program that how many number of points, how many number of numbers you want to compare. If you observe carefully here, the comparison starting from which memory location now in this program? Because 1200 memory location is given for counting or counter number. Now tell me, which memory location I'm supposed to store my numbers?
SI plus 1. Mine
Sorry?
1201.
1201. Yeah, so if you observe carefully here, first you moved SI to 1200, then SI value into CL register, then it is decreased. Why it is decreased? Tell me. Why it is decreased? Any idea why it is decreased? Listen carefully. In 200 memory location, we will give how many number of numbers you want to compare. Is that fine? Suppose if I want to compare 10 numbers, what is my CL value supposed to be?
9.
9. That's why this extra decrement CL values come. Similarly, decrement CH also come because you want to compare only 9 numbers, but you are having a 10 number. So what we give is the input as how many number you give the input. That's it. How many numbers you are comparing, that as input, and your counter values will be taken care automatically. You don't have to manually enter how many, what is the counter number. You're getting my point?
Yes, sir.
Now we are not going to enter manually your counter number. You just give how many points you want to compare. From that it will take what is the counter number and all. Then you can see this extra instruction. This instruction makes the program start your comparison from 1201. Previously your comparison starting from 1200, but now this 1200 memory location is given for counting operation. So your comparison will start from 1201 to whatever the desired memory location you are going to define. Is this clear, all of you?
Yes, sir.
Yes, sir.
So we'll run one program with this, then we'll close session for today. So let me copy paste the program since I already written. Yeah. Now you can define
So
whichever the
why,
number. Yeah, please.
so why we need to start it from 1201?
It's
Because
up to
it's
you.
having input numbers on 1200.
No, 1200 memory location, I deserve it. I make the reservation for the count total number of numbers you want to compare.
Okay, sir.
Okay, and 1201 onwards, your data points will come into picture. So anyway, we'll run the program, then you'll understand why it's supposed to be in that way. Okay. Yeah, fine. So yeah, so fine. So now you can define which are the number you want. So tell me how many numbers you want to compare. Now you have a choice. So that should be given at 12 and memory location, remember. So now tell me how many numbers you want to compare. That we are supposed to give a 12 and memory location. Okay, we'll make it 6. Done. Now tell me the numbers. Which numbers you want to compare?
8,
8,
5,
5,
9,
9,
11,
11,
2,
2,
6.
6. Done. So now we'll just try to run 1 or 2 steps, single step, then after that I'll run the full scale. Okay, just listen. So you started, your SI moved to 12 and memory location. In the next instruction, your CL value moved with which number?
6.
6. So CL is 6. In the next instruction, your CL becomes 5. You can see CL becomes 5. This is the counter value. And go to the again 12 and memory location. The 12 and memory location value again move to CH register, that is 06. Again CH value will be decreased, that is 05. Then your program will start from which location now?
1201.
1201.
So if I write the next instruction, your 1201 memory location will move to AL register. Now you can see 08 is moved to the AL register. So I'm going to run the direct full run so that we are going to get the ascending order. Did you get it or not? 2, 5, 6, 8, 9, 11. Fine, right?
Yes, sir.
Yeah, fine. So we'll give some more number. It looks like very small. So what we'll do is, so we'll keep some more number. Tell me, let's say 10 numbers. Is that fine?
Yes, sir.
So 0 is 10, right?
Yes, sir.
So now give me some numbers. We'll check the last one and we'll leave for today. Give me some
13.
numbers. Sorry?
13,
13. Okay, good.
19,
19. Okay.
21,
Sorry?
21, 21,
21. Okay.
33,
33.
44,
44.
71,
71.
63,
63.
57,
57.
14,
14. Thing done.
27.
1, 2, 7. 1 second. Let me check how many numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's done, right?
Okay, sir.
Okay. Now we'll update it and we'll try the run the full run directly. Got it, or any error is coming?
Sir.
Yes, sir.
Correct.
Yeah, okay. Done. Fine. Okay, good. So this is how you're supposed to make the ascending or descending order. I'll share this program with you. You don't worry. You can try first for the practice purpose. I would suggest you to, like what someone has suggested, that why you need to use jump carry. So I request you to try with any other instruction set which can be done the same program, like which can be which does the same job of ascending order. Okay. Once you succeed with that, please do share with me that program, because probably next batch people I'll try to show them there is an alternate way to do that also. Okay. And your job is, you are supposed to do one more program that is for the descending order. So you take the worst possible combination again. I suggest you to take worst possible, like, so take 1, 2, 3, 4 as your input and make them descending order like 5, 4, 3, 2, 1 as your program output. By the time you finish your program, your memory location is supposed to show 5, 4, 3, 2, 1. Is this fine, all of you?
Yes, sir.
So if there are no clarification, I'll close for today. I request all of you to do it on your own. You develop your own logic. I'll be really happy to see someone can develop a even simple logic than this. If I feel this is the simplest one, if someone can definitely generate a simple logic, I'll be very happy to share with the next batch people that you did it, like your batch did it this particular logic, and I'll ask them to even check for even better logic than this also. So this will improve the learning skill for the students also in the long run. Okay.
Okay, sir.
Okay, then thank you all. I'll create a assignment in the LMS to submit your descending order program, and as well as lab report for the ascending order also. Okay.
Okay, sir.
Okay, sir.
Yeah, Ryan. Thank you all. Then if anything required, please do WhatsApp, message me on WhatsApp. Okay.
Thank you, sir.
Thank you, sir.
Yeah, then thank you all.